Welcome to QuickBytes Education. Today's QuickByte is all about hyperparameters, what they are, how they are different from model parameters, and why they matter in machine learning. Let's get started. Machine learning models do not just magically train themselves perfectly. Before a model learns from data, there are settings that control how that learning happens. Those settings are called hyperparameters, and if that word sounds intimidating, don't worry. A hyperparameter is basically a control knob for a machine learning model. Change the knob and the model may learn differently. In this lesson, we'll cover 5 things. First, what a hyperparameter is. Second, the difference between parameters and hyperparameters. Third, common examples of hyperparameters. Fourth, how hyperparameters affect overfitting and underfitting. And fifth, what hyperparameter tuning means. A hyperparameter is a setting that controls how a machine learning model trains or behaves. Machine learning means computers learn patterns from data instead of being manually programmed for every single rule. A hyperparameter is usually chosen before the model finishes training. It is not learned automatically in the same way as the model's internal patterns. Instead, the person building the model, or a tuning process, chooses the hyperparameter value. Think of it like setting the temperature on an oven before baking. The oven still does the cooking, but the temperature affects how the food turns out. In machine learning, the model still learns from data, but the hyperparameters affect how that learning happens. Now let's separate 2 words that sound similar. A parameter is something the model learns from the training data. A hyperparameter is a setting that controls the model or the training process. For example, imagine a simple model that predicts house prices. During training, the model may learn how much square footage affects price. That learned value is a parameter. But if you choose how complex the model is allowed to be, that setting is a hyperparameter. So here's the simple difference. Parameters are learned by the model. Hyperparameters are settings chosen to guide the model. Let's start with a decision tree. A decision tree is a machine learning model that makes predictions using a series of yes or no style rules. One common hyperparameter is maximum depth. Maximum depth controls how many levels the tree can have. If the tree is too shallow, it may be too simple and miss important patterns. That is called underfitting. Underfitting means the model is too simple to learn the data well. If the tree is too deep, it may memorize the training data instead of learning general patterns. That is called overfitting. Overfitting means the model performs well on training data, but poorly on new data. So maximum depth matters because it controls model complexity. Another example comes from k-nearest neighbors. K-nearest neighbors is a model that makes predictions by looking at nearby examples. The letter K tells the model how many neighbors to look at. If K equals 1, the model only looks at the closest example. If K equals 5, the model looks at the 5 closest examples. The value of K is a hyperparameter. A small k can make the model very sensitive to noise. A larger k can make the model smoother, but possibly too general. So choosing k affects how the model makes predictions. Another common hyperparameter is learning rate. Learning rate controls how big each learning step is during training. If the learning rate is too small, the model may learn very slowly. If the learning rate is too large, the model may jump around and miss a better solution. A good learning rate helps the model improve at a reasonable pace. You can think of it like walking down a hill. Tiny steps may take forever. Huge steps may cause you to overshoot. The right step size helps you move efficiently. Hyperparameters matter because they can change model performance. The same machine learning model can perform very differently depending on its hyperparameter settings. One setting might make the model too simple. Another setting might make the model too complex. Another setting might make training slow. Another setting might improve accuracy. That is why data scientists do not only ask, "Which model should I use?" They also ask, "What settings should this model use?" Hyperparameter tuning means testing different hyperparameter values to find the settings that work best. For example, instead of guessing one maximum depth for a decision tree, you might test several options. Depth 2, depth 5, depth 10, depth 20. Then you compare how the model performs. One common method is called grid search. Grid search means trying a planned list of hyperparameter combinations. Another useful method is cross-validation. Cross-validation means testing the model on different splits of the data to see how well it performs more reliably. The goal is not to find settings that only work once. The goal is to find settings that work well on new data. Here's the beginner-friendly strategy. First, choose a model. Second, choose a few important hyperparameters. Third, test different values. Fourth, compare performance on validation data. Validation data is data used to check how well the model performs while you are choosing settings. And fifth, pick the settings that give the best balance between accuracy and generalization. Generalization means the model works well on new data, not just the data it trained on. A common mistake is thinking the highest training accuracy is always best. It is not. If a model is too perfectly matched to the training data, it may be overfitting. That means it memorized examples instead of learning useful patterns. Good hyperparameter choices help the model avoid both extremes. Not too simple, not too complex. The goal is a model that performs well on data it has not seen before. Here's what you just learned. A hyperparameter is a setting that controls how a machine learning model trains or behaves. A parameter is learned from the data. A hyperparameter is chosen to guide the model. Examples of hyperparameters include maximum depth in a decision tree, k in k nearest neighbors, and learning rate. Hyperparameters can affect accuracy, speed, complexity, overfitting, and underfitting. Hyperparameter tuning means testing different settings to find what works best. Grid search tests planned combinations of settings. Cross-validation checks performance across different splits of the data. And the goal is to choose settings that help the model perform well on new data. If this helped you understand hyperparameters, watch the full Data Science for Beginners playlist next. Like, subscribe, and keep building your knowledge with QuickBytes education, one QuickByte at a time.